When you think of the world's smartest animals, you probably picture chimpanzees, right? Maybe dolphins or whales. But what if I told you that one of the most brilliant minds in the animal kingdom is likely sitting on a telephone wire right outside your window? Today, we're diving into the astonishing and, frankly, mind-blowing intelligence of the common crow.
Okay, so let's really get into this. We see them everywhere, these glossy black birds, and we might think of them as noisy or maybe even a bit of a nuisance. But scientists have been asking a totally different question. What's actually going on inside that little bird's brain? I promise you, the answer is going to be a surprise.
And no, that is not an exaggeration. After years and years of dedicated research, scientists have found that when it comes to certain kinds of problem solving, crows are operating at the same level as a 7-year-old human. To put it simply, we are dealing with a profoundly intelligent creature.
To really understand this, you don't have to look very far. Crows show off their genius in our world every single day, often in ways that are so clever they seem almost human.
You've probably heard some of these stories, right? Crows are famous for dropping hard-shelled nuts onto roads, waiting for cars to crack them open, and then, get this, they often wait for the crosswalk signal to safely go and get their meal. They can remember the faces of people who've treated them badly for years, and they'll even teach their friends and family which humans to stay away from. That's a level of social memory and planning that is just, wow, it's remarkable.
Now, stories are one thing, but science needs proof. So researchers have designed these really ingenious experiments to formally test the limits of a crow's brain power. And this is where it gets truly fascinating.
Take the famous Aesop's Fable test. So, a crow is shown a treat floating in a tube of water, but it's just out of reach. What does it do? Almost without hesitation, it starts picking up nearby stones and dropping them into the tube, because it understands that this will make the water level rise. The crows even choose the heavy, sinking objects over the light floating ones, which shows they have this intuitive grasp of cause and effect.
And what researchers found was that the crow's success rate in their understanding of physics in these tests directly mirrors the abilities of a human child who is between 5 and 7 years old. It's just an incredible example of what's called convergent intelligence, where totally different species on different evolutionary paths somehow end up with the same smarts.
But their tool use goes even further than that. I mean, while a lot of primates just find and use objects, New Caledonian crows actually manufacture their own tools. They even create what are called compound tools. So if one stick is too short to get a grub out of a log, a crow will fit it inside another hollow stick to make a longer one. I mean, one crow in a lab was even seen making a tool out of 3 separate parts. That's a level of engineering that we used to think belonged only to humans and great apes.
And maybe the most impressive thing of all is that crows can plan for the future. In this one experiment, a crow had a choice. Take a small snack right now, or take a specific tool that they knew would unlock a box with a much better treat inside, but they'd have to wait. And overwhelmingly, the crows chose the tool. They actually resisted immediate gratification for a bigger payoff later. That's a really complex skill that most human kids don't master until they're about 5 years old.
So, all of this leads to this huge biological puzzle. How is a bird, with its tiny brain, capable of these incredible primate-like feats of intelligence? Well, the answer is deep inside its skull, and it's not at all what you'd expect.
You see, our evolutionary path split from birds over 300 million years ago. We mammals developed this big, wrinkly, 6-layered structure in our heads called the neocortex. That's where all our high-level thinking happens. Bird brains? They don't have one. They are built on a completely different blueprint. So how in the world are they getting the same results? This was the exact question that stumped scientists for decades. I mean, if they're missing the hardware that we always associated with higher intelligence, where is all this complex problem-solving and tool-making and future planning actually coming from?
Well, the answer, it turns out, isn't about the structure of the brain, it's about its density. And the key to understanding it all comes down to this single number.
Yup, a crow's brain, while it's small, is an absolute powerhouse. It's just packed with neurons at twice the density of a primate brain of the same size. What that means is more connections and way faster processing speeds, all in a smaller, more efficient package. They don't have a neocortex because they don't need one. Their brains are just wired for incredible efficiency.
Okay, so now we know how their brains are producing all this intelligence. But that just leads to the next big question. Why? What evolutionary pressures push this particular bird family to become the Einsteins of the avian world?
So one of the main theories for why big brains evolved in animals like primates and dolphins is something called the social intelligence hypothesis. And basically it argues that navigating a really complex social world, with shifting alliances, hierarchies, competition, that requires a ton of brain power. So does this apply to crows?
Well, at first glance, the answer seems to be no. See, unlike chimps who live in these large, politically complex groups their whole lives, adult crows tend to just settle down into simple, monogamous pairs. They don't seem to have that constant social pressure that the hypothesis says is so important. So the theory seems to fall apart here.
But the answer was hiding in plain sight. The key wasn't to look at the adults, it was to look at the teenagers. Before they pair off for life, young crows live for years in what scientists literally call juvenile gangs.
And these gangs create exactly the kind of complex social environment the hypothesis predicts. It's this chaotic world of figuring out who's dominant, who's a reliable partner, who you can learn from, and how to compete for food and status. This intense social training ground during their teenage years is what forges their powerful intellect.
So, what does it mean to share our cities and our suburbs with a non-human intelligence that's this profound? It opens up all these fascinating possibilities for cooperation and for seeing the world in a completely new way.
And this isn't science fiction. A theme park in France has already successfully trained crows to pick up litter in exchange for treats. And there are companies developing smart vending machines that will automatically reward crows for depositing cigarette butts, which could potentially solve a huge pollution problem. We are just scratching the surface of how we might partner with these intelligent birds.
When you really think about it, that aha moment, that sudden flash of understanding when all the pieces of a puzzle just click into place, that's something we all recognize. And when we see a crow figure out how to get that treat out of the tube, we're probably witnessing that exact same feeling. It suggests that maybe the joy of discovery is a fundamental experience shared across very different kinds of minds. And that leaves us with one final, really crucial question. If we could overlook such profound intelligence in a creature as common as a crow for so long, what else are we missing? It forces us to look at the animals we share this planet with, not as simple, instinct-driven beings, but as fellow minds, solving the problems of their lives in ways that are creative, clever, and absolutely worthy of our respect and our curiosity.